Dr. Erica with Rosie Research, and in this video we are taking a look at one of the activities in our imaging unit that is on Teachers Pay Teachers. So if this sort of excites you, you can check the links down below where you can download the full unit. And this activity is our image transmission activity. And I think this stuff is really important because almost every image we see now has been transmitted in some way. Whether it's these beautiful images from Hubble or the image of Pluto from New Horizons, which had to be transmitted billions of miles, which is absolutely crazy if you think about it, to images that are on your cell phone or that your kids are seeing on TV or that are getting, passed back and forth. Unless an image was taken on film, which is at this point almost obsolete. I can't even think of where you could buy film to do this. But unless the image is taken on film or somebody drew it by hand and it's the paper drawing, not somebody took a picture of it drawing, those images have been transmitted. And this activity is a great hands-on way for kids to look at how images are transmitted and gain a lot of vocabulary about pixels, what are pixels, what does resolution mean, what do we mean when we say something is pixelated, and how can we transmit data when computers only have really two digits that they can talk about, which is off and on, 0 and 1. And so this activity, they get to build their own images with a partner, and then they're going to actually transmit those images through space, just like what your phone would do if you sent an image to a friend of, hey, look at this cool astronaut. Or if we look at the image of Pluto and say, wow, that one went through space for a really long time and had a lot of what we call pixels or little square bins in it. But it gives them sort of a better understanding of that. And so in the workbook, you've got a whole prep section that gives you all of our goals and objectives. It'll even give you sort of standards that this could meet if you're looking to meet some different standards. And you have two sort of pieces of paper that are really important that you're going to have to print out from that workbook. One of them is for the sender side, so this helps them learn how do we send an image, so it gives you sort of a pretend image, which you'll notice looks like pretty much squares. There's no curvy lines, and that's because the pixels on this, each one of these boxes is what we call a pixel, and those pixels are really big. Pixels on your digital camera are really, really small, like 15 microns wide. And they're getting so small that our eyes can't actually see, if they go on a diagonal or on a curve, our eyes can't see those little teeny tiny steps that they take. But they do take those steps. And sort of the pixel size here, that gives you an idea of your resolution, right? If I wanted to draw an actual happy face, I can't really do that with the size of pixel I have. My resolution, my ability to take out those details is not high enough. But this is our sender sheet, so it tells you, if you have a blank square when you make this, you're going to say 0, so you would say 0, 0, 0, 0, 0. 0, 1, because that space is colored in, 0, 1, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1. And it asks them to sort of fill out what they're going to be saying so that they can get an idea before they build this and talk to their partner. Because there is something that we call transmission errors, and that is when we send the wrong information for that one pixel or that one block. And so your students can have these transmission errors as they go through this project, which is a great way to talk about what are transmission errors and what can we do with them. Then of course there is the receiving end of the sheet, which looks surprisingly and shockingly just like a square grid. And so what this student will do when it's time is they will be read zeros and ones, and they'll just write in 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, whatever it is that they're getting told. And then they'll go back and they'll color it in. And whatever they color should match what the other student made. In the supplementary material, you have a grid that's 1-inch squares. I'm using a pastry grid because I really like sort of the feel of it. These guys, they sort of stick to that pastry grid, which is really nice if your things are getting shifted around. But if you don't have pastry grids, you can always build on this guy and a guy on the printout, but you'll notice it's sort of easy to get them to move. So the materials you'll need are either the pastry grid or that printout of the grid. and a bunch of 1-inch square tiles. And what they'll do is they're going to make a picture for you. So you'll plug in whatever you want to make. And sort of this is sort of the fun part. You can have both of the students building at the same time if you have enough square tiles. And then they can transmit together one after the other. If you are looking for, like, you know, students always having a little something to do, that's a great way to do that. And so what do we want to build? I'm not really sure. Maybe I'll build a robot. Now, of course, I'm stuck with 1-inch squares. I can't make anything that has any fine detail. Nothing is going to be very resolved because I can't see much. So I'm sort of stuck in what I build. Everything's going to be pretty blocky. But that's sort of part of the fun, is can you figure out how you can make something that looks like something as you go. Now, there is one thing to note, especially if, like, what we have is different colors of tiles. They're not transmitting the colors. So when they're making this, they don't want to make a rainbow, because when it gets transmitted, it's going to be transmitted as a brick. And it's just going to be black. So there's no colors that we can see. That is an idea of what you could do, is ask students, how would we transmit colors? So we are only using zeros and ones here. Is there a way to still use zeros and ones and transmit colors? And one of the ways that computers do that is they assign numbers to each color. So for example, for here, I only have 4 colors. So maybe I say yellow is going to be 1100, and orange is going to be 1111. And so as I'm reading it out, instead of saying just 110, I'd have to say 1111. Your student knows, okay, that one's orange. 1100, that one's yellow. But now you have to transmit a lot more information, right? Because you're transmitting 4 bits of data, 4 zeros and 1 for each square. So you definitely want to do that for the students who are getting through this quickly. It lets them think about how they can apply color to it, and it's going to take much longer because you got to do 4 times the amount of data for the same image. And the way that a lot of cameras actually do this is they have filters on CCD cameras, that like our Hubble and all of our space stuff. They have filters, and so they'll put a filter in front, take an image, put a different filter in front, take an image, and those filters will say everything but red light is going to get blocked. So this is our red, this is how much we get in red, this is how much we get in blue or green, and then you've got to take all of that data, 3, 4, 5 times the amount of data, and overlay them. And that's how we get those sort of color images of the universe or other planets. So that's sort of the gist of this project in our imaging unit. We've got a lot of other fun projects. If you're thinking about whether or not you want to download it yet, there's some stuff about binary, learning binary in terms of numbers, how to write digits in binary. We've got how to write the alphabet in binary. We've got some really great corny, punny jokes about binary, which I'm really proud of. And so there's a lot of stuff that you guys are going to be able to do. We even have data from from Mars, real NASA data that they can color in, similar to what this is. And using more digits per square to color in some of the first, what we get is from Mariner 4, which is one of the probes we sent on Mars. But they can do that in this activity download. So there's lots of fun ideas for you guys, and hopefully it will bring imaging into your classroom in a really fun way and sort of meet a lot of those standards about how do we represent data in different ways, how can we represent, use numbers to represent things, and those sorts of aspects. So we hope that you will join us as we do these activities and download it from Teachers Pay Teachers. You can also follow us on Instagram if you want to see what we're up to at the moment. Have a great day.